Hello! Let's continue our Sudoku adventure with Caesium by Wall. And let's go over the rules first. So we have an irregular 6x6 Sudoku. So in addition to every row and every column, placing the digits 1 to 6 exactly once each, we also have these demarcated regions where the digits 1 to 6 have to appear exactly once each. So that's why it's called irregular, because it's not the standard boxes. But they work just like a box, just different shapes. In addition to that, we do have these arrows in the grid. So digits on an arrow sum to the value in the circle. So if I put, say, 2 and 3 here, let's not do 3. 2 and 4 there, that does add to 6. And so there we go. Those are the rules. And if you would like to try the puzzle yourself first, definitely recommend it. Check the link in the description and come back and watch my solve. All right, so how do we want to get started? Well, let's hit restart first. Okay. So I feel like the geometry of these ones are interesting. So these are identical, just upside down. So yeah, so these two cells here, I'm actually going to color them. Let's make this cell green and this cell purple for a second here. So the question is, where do green and purple go in this row? Well, they can't repeat in the region, so they go here. So these are green and purple, but this one can't be purple. So this is green and this is purple. What that immediately tells us is that these are the sum of the same digit with itself, because purple is the same digit, green is the same digit. So this might be like 1 plus 1 equals 2, 2 plus 2 equals 3, or 2 plus 2 equals 4, or 3 plus 3 equals 6. But this given 3 here is actually removing 3 from green and purple. So they can't actually be 3. So I think this is a 1-2 pair adding to 2 or 4, which is already very nice. And then we have the identical thing over here. I'm going to give them different colors. It doesn't mean they're different values. These could be a 1-2 pair for all I know. But it does mean that they are different from these are different from each other and these are the same as each other. So that's why I'm doing that. And then we have the exact same thing happening here. This is a 1-2 because it does see a 3. This doesn't see a 3. So this is from 1, 2, 3. And then these are from, this is a 2-4 and this is a 2-4-6. Okay, I'm immediately seeing that there's a 2-4 pair here. And so that does remove 2 from orange, which means that this can't be a 4. All right, so I'm not seeing anything else immediately with these. Okay, so let's look at green in this box. Because green looks up into this box, none of these can be green. So green is one of these two. But can this really be green? It would be 1 or 2, and you can't add to 1 or 2 with 2 distinct digits. The minimum is 3. So green is not here. So that means this one actually is green, and it's a 1 or 2. Can I repeat that with purple? Purple looks up here. Purple is one of these two. If it was here, it would have to be a 2, which is okay. But yeah, let's mark these as one of these two is purple. Then of course we have the exact symmetric thing happening down here. So, this is interesting. So blue looks down here, and so blue is in one of these two, but actually there's a 1-2 pair looking at this cell here. So this can't be blue either. So it actually forces this to be blue, and that's key, because that means blue has to be 2. That places a 4 here, because 2 plus 2 is 4. Places a 4 here, which means purple is blue. So let's just get rid of the 2 colors, because we're just going to finish this real quick. So if we ask where 2 goes in this box, it can only go here, which means orange is 1 and green is 1. So we can get rid of these colors as well. So we have all of these sums done. What do we want to ask here? So this 3 looks up, so that's a 3. Whoops, that's a 3. Not black. This is 5 and 6, and this is 5 or 6, but it can't be 6. Can't put 6 on an arrow. So that's a 5, and they add to 6. And so then this is 3 and 4. Nice, we know the order because of this 4. 3 and 4. This is 5 and 6. Looks like we're wrapping up. So let's do these columns, because we need a 1 and a 4. We know the order. This column we need 4, 5, 6. I don't know. Oh, we can place the 4 actually, but I think the 5, 6 isn't resolved yet. This is also a 5, 6. This is also a 5, 6, but this 6 looks down. So that's 5, that's 6, that's 5, that's 6. Nice. We need a 3. Oops, I clicked wrong. That goes there. And we need a 5. Let's see, down here we need a 3 and a 6. So we know the order because of this 6. And these we should just know. We need 3, 4, 5, 6. So it looks like the 3 goes here, the 4 goes here, the 5 goes here, the 6 goes here. Nice, 4 minutes 20, not too bad. I think I think it's kind of hard to spot 2 things to sort of get started on this puzzle. But after that, it flowed nicely. So the 2 things you had to spot were this geometry here, where these 2 had to be the same digit, these 2 had to be the same digit, and because of the given 3, it limited them to a 1-2 pair. Similarly up here, the 3 didn't quite affect this one, but this had to be 1, 2, and this had to be 1, 2, 3. That affected these sums. That gave us a 2-4 pair, which saw that. But I think the other thing to spot was that because these 2 were the same, they had to go down here somewhere, and they couldn't go here, and that made them 2. And that just spiraled around the whole puzzle after that. So had I spotted that first, I may not have had to place the green and the purple in this box early on. But, you know, I looked at the top right before the top left. That's fine. Or before the bottom left. Anyway, that was a fun puzzle. Thank you all. Let me know how you did on this one. I could see getting stuck a little bit at the start, maybe trying to hunt what to do, but hopefully you figured out a way through, or maybe my video helped push you through that. And of course, if you enjoyed this content, then why not leave a like and subscribe?